Black holes are fascinating objects in the universe, characterized by their immense gravitational pull. Here's a breakdown. Formation: black holes form when massive stars undergo gravitational collapse at the end of their life cycle. When such a star exhausts its nuclear fuel, it can no longer support its own weight against gravitational collapse. The core collapses under its own gravity, and if the core's mass exceeds a certain threshold, known as the Chandrasekhar limit, it collapses into a singularity. Singularity: at the center of a black hole lies a point of infinite density, called a singularity. Here, the laws of physics as we understand them break down, and our current theories can't fully describe what happens at this point. Event horizon: surrounding the singularity is the event horizon, which is the boundary beyond which nothing, not even light, can escape the black hole's gravitational pull. Once something crosses the event horizon, it's essentially trapped, and no information or light can escape from it. Types of black holes. Stellar black holes: these are formed from the gravitational collapse of massive stars. They typically have masses ranging from a few times that of the Sun to tens of solar masses. Supermassive black holes, found at the centers of most galaxies, including our own Milky Way. These black holes have masses ranging from hundreds of thousands to billions of times that of the Sun. Their origin is still not fully understood, but they likely grow over time by accreting matter from their surroundings. Intermediate black holes: these have masses between stellar and supermassive black holes and are less common and less understood. Primordial black holes: hypothetical black holes that could have formed in the early universe due to extremely high densities but have not been observed yet. Properties: black holes have several intriguing properties, such as time dilation. Time passes more slowly near a black hole, gravitational lensing, bending of light around the black hole, and spaghettification, the stretching of objects into long thin shapes as they get closer to the singularity. Hawking radiation: according to theoretical physicist Stephen Hawking, black holes aren't completely black. Due to quantum effects near the event horizon, black holes can emit a faint radiation known as Hawking radiation, causing them to lose mass over time and potentially evaporate completely. Studying black holes provides valuable insights into the nature of gravity, spacetime, and the fundamental laws of physics under extreme conditions. The Bermuda Triangle, also known as the Devil's Triangle, is a loosely defined region in the western part of the North Atlantic Ocean. It's infamous for purportedly being the site of numerous mysterious disappearances of ships and airplanes. Here's what we know. Location: the Bermuda Triangle's boundaries are not officially defined, but it's generally considered to be roughly bounded by Miami, Bermuda, and Puerto Rico. It forms a triangular area in the Atlantic Ocean. Disappearances: over the years, various ships, planes, and even people have allegedly disappeared within the Bermuda Triangle under mysterious circumstances. Some of the most famous incidents include the disappearance of Flight 19, a squadron of U.S. Navy bombers, in 1945, and the vanishing of the USS Cyclops in 1918, a Navy cargo ship with over 300 crew members. Theories: numerous theories have been proposed to explain the disappearances attributed to the Bermuda Triangle. Some of these include natural explanations. These include the presence of methane hydrates, which could potentially cause ships to sink if released in large quantities, sudden violent weather patterns, and underwater geological formations. Human error or sabotage: many incidents within the Bermuda Triangle could be attributed to human error, navigational mistakes, or even deliberate acts of sabotage. Magnetic anomalies: some theories suggest that there may be unusual magnetic anomalies in the region that could interfere with compass readings and navigation systems. Paranormal or extraterrestrial theories: these hypotheses propose that the Bermuda Triangle may be the site of supernatural or extraterrestrial activity, such as time warps, alien abductions, or portals to other dimensions. However, these ideas lack scientific evidence and are largely regarded as speculative or fictional. Criticism: many skeptics argue that the Bermuda Triangle's reputation as a site of mysterious disappearances is exaggerated. They point out that the number of incidents within the region is not significantly higher than in other parts of the world's oceans, and that many alleged disappearances have plausible explanations. In conclusion, while the Bermuda Triangle remains a subject of fascination and speculation, the scientific community generally regards its reputation for mysterious disappearances as more myth than reality, with most incidents having rational explanations rooted in natural or human causes. The mystery of the galaxy encompasses a wide array of questions and phenomena that intrigue scientists and astronomers. Here are a few key aspects. Dark matter and dark energy. A significant portion of the universe is made up of invisible, unknown substances called dark matter and dark energy. Dark matter interacts gravitationally but does not emit, absorb, or reflect light, making it invisible and difficult to detect directly. Dark energy, on the other hand, is believed to be responsible for the accelerated expansion of the universe, but its exact nature remains elusive. Galactic evolution. Galaxies, including our Milky Way, evolve over time through various processes such as mergers, collisions, and star formation. Understanding how galaxies form, grow, and change over billions of years is a fundamental question in astrophysics. Black holes. These are regions of space where gravity is so strong that nothing, not even light, can escape from them. The study of black holes raises questions about their formation, properties, and their role in shaping the universe. Galactic dynamics. Galaxies are not static entities, they are dynamic systems of stars, gas, dust, and dark matter. Understanding the dynamics of galaxies involves studying their rotations, orbits, and interactions to decipher their structure and behavior. Exoplanets and habitable zones. Another mystery within galaxies is the search for exoplanets, planets outside our solar system, and the identification of habitable zones where life as we know it could potentially exist. Discovering and understanding the diversity of exoplanets and their potential for harboring life is a key focus of astrobiology. Galactic magnetic fields. Galactic magnetic fields play crucial roles in various astrophysical processes, including star formation, cosmic ray propagation, and galaxy evolution. Understanding the origin, strength, and influence of these magnetic fields remains an active area of research. These mysteries, among others, drive scientific exploration and lead to new discoveries that deepen our understanding of the universe and our place within it. Astronauts, pioneers of space exploration. Introduction. Space, the final frontier, has always captured the imagination of humanity. The vast expanse beyond our atmosphere has beckoned adventurers, scientists, and dreamers alike. Among those who venture into this unknown territory are astronauts, remarkable individuals who embody the spirit of exploration, pushing the boundaries of human capability and knowledge. In this comprehensive exploration, we delve deep into the world of astronauts, examining their history, training, experiences in space, and the profound impact they have on humanity's understanding of the cosmos. The evolution of space exploration. Humanity's fascination with space dates back centuries, but it wasn't until the 20th century that the dream of space travel became a reality. The launch of Sputnik 1 by the Soviet Union in 1957 marked the beginning of the space age and ignited the space race between the United States and the Soviet Union. In 1961, Yuri Gagarin became the first human to journey into space, paving the way for subsequent manned missions. 2. The birth of astronauts. The term astronaut originates from the Greek words astron, meaning star, and nauts, meaning sailor. It was first used by NASA to describe the pioneers of America's space program. Other spacefaring nations adopted their own titles for space travelers, such as cosmonaut in Russia and taikonaut in China. 3. The selection process. Becoming an astronaut is no easy feat. The selection process is rigorous and highly competitive, with thousands of applicants vying for only a handful of positions. Candidates undergo extensive medical evaluations, psychological assessments, and interviews to determine their suitability for space missions. Physical fitness, intelligence, adaptability, and teamwork are essential traits sought in potential astronauts. 4. Training for the unknown. Once selected, astronaut candidates embark on a journey of intense training that prepares them for the challenges of spaceflight. Training includes simulations of launch and landing procedures, zero-gravity environments, spacewalks, robotics operations, and survival skills. Astronauts also receive instruction in scientific disciplines relevant to their missions, such as astronomy, physics, and biology. Life in space. Living and working in the harsh environment of space presents unique challenges for astronauts. Microgravity alters the human body in profound ways, affecting muscle mass, bone density, and cardiovascular health. Astronauts must adapt to weightlessness and learn to perform everyday tasks in a new and unfamiliar environment. The psychological effects of isolation, confinement, and the demands of spaceflight can also take a toll on astronauts' mental well-being. 6. Scientific exploration. Astronauts serve as ambassadors of science, conducting experiments and research that advance our understanding of the universe. From studying the effects of microgravity on the human body to investigating the origins of the cosmos, their work contributes to a broad range of scientific disciplines. The International Space Station, ISS, serves as a laboratory in orbit, where astronauts conduct experiments in physics, biology, medicine, and materials science. 7. The challenges of spacewalks. One of the most demanding tasks astronauts face is the spacewalk, or extravehicular activity, EVA. During EVAs, astronauts venture outside the confines of their spacecraft to perform maintenance, repairs, and construction projects. Operating in the vacuum of space presents numerous hazards, including exposure to extreme temperatures, micrometeoroids, and the risk of equipment failure. Astronauts must rely on their training, experience, and teamwork to ensure the success and safety of their spacewalks. 8. Collaboration and diplomacy. Space exploration is a collaborative endeavor that transcends national boundaries and political differences. The International Space Station, a joint effort involving multiple countries, exemplifies the spirit of cooperation that defines modern space exploration. Astronauts from around the world work together on the ISS, fostering international goodwill and promoting peaceful cooperation in space. 9. Looking to the future. As humanity's reach extends beyond Earth, the role of astronauts will become even more vital. Future missions to the Moon, Mars, and beyond will require the expertise and courage of astronauts to explore new frontiers and expand our understanding of the cosmos. Technologies such as advanced propulsion systems, habitat modules, and life support systems will enable longer-duration missions to distant destinations. Inspiring the next generation. Astronauts serve as role models and inspire future generations to pursue careers in science, technology, engineering, and mathematics (STEM). Their courage, dedication, and pioneering spirit capture the imagination of people around the world, sparking a sense of wonder and curiosity about the universe. Educational outreach programs, public appearances, and social media engagement allow astronauts to share their experiences and inspire others to reach for the stars. Conclusion. Astronauts are the vanguard of humanity's quest to explore the cosmos. Through their bravery, ingenuity, and scientific curiosity, they push the boundaries of what is possible and inspire us to reach for the stars. As we look to the future, astronauts will continue to lead the way, opening new frontiers and expanding our understanding of the universe. In the words of astronaut Neil Armstrong, the first human to set foot on the moon, that's one small step for man, one giant leap for mankind.